Happy Wednesday, everybody. Welcome back to another ENCOR study group. Today, we are going to be finishing up our section on software-defined access. It has been a whirlwind of a set of topics that ENCOR wants us to know. And to be fair, over the last couple of months, we've really dove a lot deeper into SDA than probably even the ENCOR exam is going to test us on. But we'd always rather know more information than less information when going into an exam. So if you're studying for your ENCOR, you maybe have missed a couple of these sessions, be sure to go back and watch the software-defined access videos here on this YouTube channel because there's a lot of information that we have covered that's going to be valuable to passing the exam. Today, we're going to be talking about SD-Access components, which is a part of Cisco's blueprint from an SDA perspective. SD-Access components, we think about what that means. Usually it's going to come down to one of two things. It's either the hardware that we're selecting to deploy into our networks, or it's the device roles that we're deploying onto those devices. So for example, a fabric edge node or a fabric border or fabric control plane node. So the question would be, maybe something they might ask on the ENCOR exam would be, what would be a valid option for a fabric border node? And your choices are Catalyst 9Ks and Catalyst 3650s and ISRs and all of these. And so you'd have to be able to figure out, okay, based on this information, do I know which type of hardware can be deployed into which role? And so that's exactly what we're going to be covering today. So when I look at the agenda, again, we're going to talk about switches, we're going to talk about routers and wireless and such. That would be the hardware components of the network nodes that we're deploying onto the network. We also have these extended nodes, kind of an interesting concept that we need to talk about. We don't have to know about extended nodes in great amounts of detail, but we might need to identify which types of hardware are extended nodes on a Cisco exam. Next, controllers. We do at some point have to specify the hardware or the software that we're deploying to our controllers. And lastly, device roles, like I mentioned, which of these devices can fit which role in the SDA fabric. Now, if this is your first time joining us as part of this session and you're in the live conversation, then feel free to join into the chat and join into the conversation anytime. Ask whatever questions you want. This video has been pre-recorded. I am in the chat right now, ready and available to answer questions that might come up as we talk through these conversations or talk through these topics. But and also, by the way, feel free to ask questions about anything on the ENCOR if you're struggling with something else. I mean, this is in some way, I suppose, supposed to be a study group covering all of ENCOR. So wherever you are in your journey, thanks for joining us, whether live or pre-record or you're watching it after the fact. Either way, if you are watching this after the fact, leave comments if you have any questions. I always go back and try to watch for comments and answer any questions that might come up. Whew. Okay, so without further ado, let's dive into this conversation. So we said we're going to start with this conversation of switches. Now, when it comes to switches and what's covered from an SD-Access perspective on Cisco's portfolio, a lot of this is going to come down to one platform. You all probably already know what I'm going to say. These Catalyst 9000s, or sometimes they're called Catalyst 9Ks. So a little history lesson here. Cisco used to have Catalyst 2Ks and 3Ks and 4Ks and 6Ks, and there was a 5K, but it was seriously way long ago, predating even a lot of these platforms. And they've taken all of the purposes of those different platforms. You know, the 2Ks were edge switches, the 3Ks were layer 3 edge switches, 2Ks being layer 2. 4Ks were chassis, 6Ks were core distribution type of deals. And they took all of those different lines of switches and they've collapsed them all into one line of switches. That would be the Catalyst 9Ks. So what's so special about these 9Ks? I mean, why should we invest in Catalyst 9Ks instead of everything else? And, you know, the short answer is always going to be, what is Cisco's most recent platform? And that is their most recent platform. If you called a Cisco partner today and said, hey, I need a switch, I guarantee you they're going to start the conversation on what the Catalyst 9K is going to be the best fit for your needs. But at the same time, there are a couple of other things that we need to be aware of that make these 9Ks special. The biggest one is something we call the Unified Access Data Plane, or UADP, and that's an alphabet soup here, right? It's an Application-Specific Integrated Circuit, or ASIC. So it's the UADP ASIC. Yeah, 8 letters in a row. It's always great from an acronym perspective. But UADP is a unique concept in that it is a programmable ASIC. Now, that's a little bit of an oxymoron if you know what an application-specific integrated circuit is. So I'll give you an example. Back in the day, I was doing a lot of wireless deployments. One of my talking points as a, Cisco, I was working for a Cisco partner. We'd go into maybe a head-to-head, why you should buy Cisco access points versus why you should buy another competing product. And one of the points I would make is that it's a whole lot better to run things in hardware. Most of us who have been in the industry for a long time understand this. If you're going to have a device, whether that's an access point, for example, or something else, and you're bringing a stream of data in, you're always going to have two components or two potential components in this box. You're going to have CPU that's running software, and ideally you're going to have a set of ASICs. Now, not every company is going to have this. For example, back in the day, I could say, hey, Cisco's got hardware-driven ASICs that can take this stream of data and output it before the CPU ever needs to look at it. All right, the CPU, this is very flexible. It can do pretty much anything. And again, the reason it can do pretty much anything is because it's software. In fact, if we're doing everything through the CPU and we need this box to do something new that had never been done before or hadn't been done when we launched it, we could just push a software patch. Say, hey, guess what? Now it does XYZ. It didn't used to do XYZ, but now it does. That's the power of software and CPU. But the problem here is there's major performance problems with relying on a CPU. A CPU is a serial type of deal. It takes a packet in, it looks and figures out what it needs to do, and it sends it out. And it's very slow, comparatively speaking, to having this in hardware. An application-specific integrated circuit, little known fact potentially, I went to school for electrical engineering and never spent a day in my life doing electrical engineering for what it's worth. In fact, my wife and I just replaced a bunch of light switches with the smart light switches that Alexa can control. So once the hacker hacks my house, they'll be able to control my lights, I guess. That's just living in 2020. But yeah, so I was like, all right, just remember all of the electrical, like how electrical engineering works while I'm replacing these light switches. Because when you have dimmers, it's a little bit complicated how they're wired together. I don't know why I told you that, other than to say that when I was in school doing electrical engineering, I got to actually work on integrated circuits. This is what they call solid-state electrical engineering, and an integrated circuit is primarily focused on, well, not focused on, it's primarily built on transistors. All right, so again, this is a little bit of CPEG, computer engineering, electrical engineering, but the idea here is that we take a bunch of transistors, we arrange them in a pattern to accomplish a very specific task. This is why we call them application-specific integrated circuits. An application-specific integrated circuit would be, well, I'll give you the example again. In college, the application-specific integrated circuit, the ASICs, I'll start calling them that. The ASICs that we were creating for fun was just a little chip that if you put it into a little fixture with a speaker in it, and you soldered the wires in the right spot, it would play our school fight song. But that's all it was capable of doing. That's 100% it. It could not run math calculations for me. It couldn't tell me what 2 + 2 is, but it could play our school's fight song. And that's a lot of fun. But again, the point I'm trying to make in all of this is that an ASIC takes a bunch of transistors and arranges them in such a way that they accomplish something. So applications or ASICs are absolutely not flexible. Oops, let me do it like this. I'll match what I did up there. They are absolutely not flexible, but they do have an extremely high performance. So back to me now being a fresh electrical engineering graduate, finding myself not knowing who Cisco was or why we should care, but hey, I'm going to learn what this Cisco thing is, and going to customers and talking to them about Cisco access points is how I got my start. It's a lot of fun. But I was able to say, look, this access point has ASICs in it. It's hardware driven. So as client traffic is coming through, it's not going to get bogged down. Cisco access points back then could run 25 clients per access point because of these ASICs, whereas our competitors could probably run 5 to 10 because it was primarily in software. And yes, it's cheaper that way, and our competitors' access points were cheaper than ours, but ours were higher quality, and this is why. So, back to the UADP and what makes it special. I hope that helps us understand why saying we have a programmable ASIC is an oxymoron. Because ASICs are transistor based, it's hardware driven, it's wired to do a certain set of tasks. And so if we're going to build a hardware platform on ASICs, then it's going to be able to accomplish the things that I want it to accomplish, but not anything else. That access point, again, we can't use those ASICs to tell us what 2 plus 2 is, but boy, can they process wireless traffic. So this idea of programmable ASICs, it's not something Cisco invented. It just takes a little bit, it requires a little, I'm not going to go into the details, but it requires a different layer of application of these transistors in such a way that you can apply some level of changes to it after the fact. And by applying changes to it, that way we can make changes, but we can't, but we don't lose the performance. So it sounds like it's the best of both worlds, and to some extent it is. But keep in mind that this programmable ASIC, this isn't like a race car where I can make very quick turns, or maybe not if I'm going 200 miles an hour. I don't know if that analogy works. But think of it more like a semi-truck, right? Because I have to make slow turns with a semi-truck. I can't really just whip around and do whatever I want with these programmable ASICs, but I can take something that I'm already good at and divert it into something that's related. All right. So UADP, specifically the Catalyst 9Ks, are running UADP 2.0. Okay, so it's the second version of these programmable ASICs, and this is going to come back up later where this is all going to come full circle as far as what the value of having programmable ASICs is. But either way, understand that. It's not just, by the way, these switches that have UADP. Our wireless LAN controllers, our newest access points and wireless LAN controllers are built on the same chipset. So we've got the UADP 2.0 ASICs inside of a lot of the different hardware platforms that we're positioning in SD-Access. In fact, I shouldn't even say it like that. It's required. Okay, the UADP is required to deploy into SD-Access from a fabric edge switching perspective. So when we think about VXLAN and when we think about Lisp, these are things that the UADP is very, very good at. Okay. What else? So this isn't SD-Access related, but something to keep in mind from a Catalyst 9K perspective is that we are running iOS XE. Now, for those who don't know, the way iOS XE works is when we talk about Cisco iOS, the operating system that's running on these devices, it used to be that iOS was essentially the entire software package. If you have a router and it's running iOS, aside from Raman and whatever underlying pinnings are happening, it's basically just iOS. iOS XE, and I don't pretend to know what XE stands for if it is an acronym, but I can tell you that the X comes from Linux, because what we're doing is that we're running iOS on top of a Linux kernel. Essentially, what we're doing is, if the hardware is down here, and we're deploying, I'll just do it like this. We're deploying iOS straight to the hardware in traditional Cisco platforms, like the old 3750 switches, for example, was this way, and the routers, the not Catalyst, I guess, but the Cisco 2800 series routers ran like this. But now we can deploy iOS as a software package running on Linux. We actually deploy Linux onto the hardware first, and then we deploy iOS as a module. What this allows us to do is install other software modules. It's specifically the Catalyst 9000s, they're running on x86 hardware, which means we can truly apply and run, in some cases, containers and virtual machines on these platforms. Now, there are going to be very specific applications where we'll do this, and so just keep that in mind. We're not going to be going and installing Fortnite onto a Catalyst switch. I don't think. Maybe it is supported. I don't know. Maybe we should find out. But we think about like Wireshark. We could deploy a Wireshark module onto this platform, for example. And so Cisco gives some applications for this, but for the most part, it's just left as a tool for us to be aware of. And if we have something that we want to deploy onto our switches, we're able to do this. So be aware of that. Again, this isn't this doesn't have anything to do with SD-Access, this is just something to do with the Catalyst 9000s. Okay. Moving on. Kind of moving on. Because we're going to keep talking about the Catalyst 9Ks here. So I mentioned earlier, well, let's just go through this first of all. So when we talk about the Catalyst 9Ks, we have a lot of different families in the 9Ks. We have the 9200s, for example, the 9300s, the 9400s, the 9500s, and the 9600s, okay, as of the time of this video. And this is switching products only, so later we're going to see that the wireless, for example, gets 9100s and 9800s, so at this point, we're just waiting for 97s and 9900s to come out. We'll see what those look like. So the purpose of each one of these families is going to be different. Again, Cisco, it used to be that if you talked about a Catalyst 2K, effectively the 2900 series routers, or switches rather, 2950s and the back in the day, 2960s, 2960Xs and S's and such. Any of those would be edge layer 2 switches. And that's what we're going to find. We're going to find like the 9200s, for example, are layer 2 edge platforms. Now, layer 2 is going to be in quotes, just like it was for the 2960X, because the layer 2, even though it's layer 2 focused, it actually can run some static routing and such. And so there are some layer 3 capabilities on the 9200, but we need to be aware that it's not really its intended design. Meanwhile, we've got a true layer 3 edge device in the 9300s. So we think about the Catalyst 3Ks, the 3650s and the 3850s were developed as that layer 3 edge. And so that's what we see with the 9300s. With the 9400s, we're going to see chassis switches. And if we think about edge, and specifically this is edge chassis switches, not core switches, for example. When we're thinking about that, we think about the Catalyst 4Ks, so the 4500 chassis switches. And you might already be detecting the pattern here. Hopefully it's becoming clear as we talk. The Catalyst 2Ks, let me just do it like this. The Catalyst 2Ks became the 9200s. The Catalyst 3Ks became the 9300s. The 4Ks became the 9400s. And so when we look down to the 9600s, you can bet that this was the spiritual successor, so to speak, of the 6500s and the 6800s, because this is a chassis switch that is built for core applications. So we see the pattern. We know, okay, if you're going to deploy a Catalyst 4500 chassis somewhere and you need the modern day equivalent of that, you can bet you're going to start in the 9400 line. And so there's a one-to-one relationship there for the most part. So you're probably looking at this and saying, okay, Jeff, what's the 9500 then? This is a little bit different, but just from a numbering perspective, this is intended to replace the 4500Xs. So if anybody used those 4500Xs, they're like single rack unit, fixed configuration, high bandwidth core and distribution applications. So usually you get like, again, one rack unit with like 12 or 24 ports of 10 gig or 40 gig connectivity. That's the 9500s. That's what it's built for. So one rack unit core. And I'm not necessarily locking. Let me change it from one rack unit. Let's just call this fixed config, because they might have two rack unit 9500s at some point if they don't already. Fixed config, and then core switches. Whoops. Okay. So that's the gist of the 9500 switching line. And so when we're looking at building a network, for example, and we need edge switches everywhere, we're probably going to be looking at 92, 93, or 9400s, depending on the size of our network. 9200s, by the way, they do have a lighter version, like the 9200Ls. Always be very wary of those kinds of switches, because they usually have limitations that, outside of very small business type of applications, they can really burn you. I know, again, working for a Cisco partner, back when the 2960 switches had a LAN light version, for those who remember that, we had a customer get really burned by that. I wasn't involved with that. I just kind of found out about it after the fact. But they deployed a bunch of LAN light switches and found out that it wasn't going to fit their needs. And that was built into the hardware. And there was no programmable UADP ASIC at the time. And so truly they had to rip out all of these brand new switches they deployed. And there was a lot of fault to go around on everybody's part as far as how that actually went into production without the proper research. But let's see here. So what are we looking at here? Oh, yeah. All right. So any questions or thoughts on switches, UADP, etc.? And the next is the Catalyst 9Ks are where we are. If you're gonna buy a Cisco switch today, you're gonna call up your Cisco rep. They're gonna want to talk about Catalyst 9K switches. I guarantee it. Next topic of conversation. We talked about switches. Let's talk about routers. What's going on in the router world? From an SDA perspective, which is the focus of the conversation here, we are going to be looking at ISRs, and specifically the 4300s and the 4400s. We are going to be looking at the ASRs, and specifically there, the 1K ASRs. There is a 9K version of the ASR. It's interesting because even though Cisco calls them ASR 1Ks and 9Ks, they're very different platforms. They probably should not have shared a family name. I think Cisco's just trying to simplify their portfolio. The ASR 1Ks, like the 9Ks, were more focused on performance, but they run completely different operating systems. The ASR runs iOS XE, like we talked about, and the ASR 9Ks run iOS XR, which is a service provider version of iOS. Because the ASR 9Ks were developed to be, again, I'm getting a lot of history here. Those 7200 routers, anybody remember those back in the day? That's what the 9Ks were designed to replace. And so they're service provider, internet, edge routers, depending on the application. That's the idea. And beyond that, we've got the ISR V. That would be a virtual ISR. And we have the cloud services router and V, I'll just call it. Sometimes it's V, sometimes it's 1000 V, depending on, I guess, the application. Honestly, I'm not sure which one is official. I see more 1000 Vs than Vs, but I do see it abbreviated this way as well. Now, on top of this, we've actually got we've got a whole new line of routers that we call the Catalyst 8000s. Now, interestingly, Cisco doesn't like to call these routers. They call them edge platforms. And I actually, one of the Cisco employees who are, I don't really know their role, they didn't ask me anything in the Cisco forum, and so I actually went, you can Google this probably and find it, but I was like, hey, why are you all calling these edge platforms? Why are we not calling these routers anymore? And effectively, they're just like, it's a little bit of a generic answer, but the gist of it is they wanted to rebrand the ISRs, but they don't want to keep using the ISR name. And so rather than calling them routers, they felt like, well, these do a whole lot more than routers. Again, think about integrated services router. They do VoIP, they do servers, they do all kinds of switch platforms, or switch modules you can deploy. And so there's a lot that goes into these boxes that takes them way above what just a router does. So they're just trying to avoid the word router to make you realize that there's a lot that these accomplish. Let's go through each one of these one by one and kind of explain the purpose of each role, why we'd want to consider them, because they all have a place. They really do at this point. So the ISR routers, ISRs are focused on features. When you buy an ISR, you're usually buying it for one of a few different reasons. You're usually deploying it out at like a remote site, a branch router. One of the most popular features to deploy would be voice over IP. So if you have a if you have a remote site and you're running Cisco voice over IP or IP telephony, then let's say the WAN link goes down. Well, we still phones are very important. Even today, when everybody has a cell phone, the cell towers might be down. You just never know what's going to happen. And so we always want to make sure that our phone lines are available inside the building. So if the phones are available inside are going to be available inside the building, and our WAN circuit just went down because of whatever incident whatever emergency we're dealing with, usually maybe a weather-related thing, our WAN circuit just went down. So how do we stay online to the PSTN? Well, our router that's sitting out there is going to have not only our not only our WAN circuit, which just went down, but it's also going to have connection to the PSTN, the public switch telephone network. And so as packets come in, normally we would have sent them out the WAN link to get switched at the headquarters out here. Headquarters has its own connection to the PSTN. But since our WAN circuit is down, we're going to redirect out this link, which is usually a much smaller link. We're not going to be able to handle more than one or two phone calls at a time. but this isn't available for us to be able to call our best friend and tell them how much we appreciate them. It's there so we can call emergency services and get an ambulance there potentially. And so we want to make sure that we've at least got that capability. So this is called Survivable Remote Site Telephony, or SRST, and it's a very common feature. But this PSTN connection is not usually IP based. It's usually an analog circuit or something. It could be IP based, but even if it's IP based, we need to be able to do the signal conversion from IP to potentially analog phones in-house. So there's a lot that, if you're not familiar with the collaboration world and specifically IP telephony, there's a lot of magic that needs to happen on this router, and we're going to find that on the integrated services routers. Now, that's just one example. The ISRs are also built with security features in mind, so we can run firewall services on this. We can do VPNs, for example, and also even built-in wireless and built-in switching I mentioned. And we can have let me finish writing this. We could have some of these ISRs have modules. You can just click it in, and it's got 2 antennas, and it's doing wireless for the whole site, or at least assuming it's physically a small location, because it'd just be one device. But you can also run a wireless LAN controller in some of these. And so switches, right? I could deploy an entire switch, but I only have 5 people there, so I'm just going to install a little switch module and give each one of them a switch port. And the other one I mentioned, by the way, which is really cool, is servers. Cisco sells UCS servers. It's one of my favorite technologies they make. And they have UCS servers that will slide right into an integrated services router. It's absolutely incredible. So tons of features on these ISRs. So then they have this ASR concept. So what's the ASR 1Ks? Well, the ASR 1Ks are going to be more focused on performance. For the most part, they are not going to have any of the features we talked about. They will have some security features, but their bigger features that they're focused on are like IP routing table size. I don't even know how to say that. IP routing table size. And making sure that our packets per second is really, really high. We're going to get a lot more throughput on an ASR 1K than we will on an ISR. And so, again, it's just what are we focused on? We're focused on features or performance, which is why these two platforms go hand in hand. Again, I'm not like trying to say Cisco made a mistake by calling the ASR 1Ks an ASR. It fits more in the ASR line. It's just, arguably, we have 3 different platforms. We have the ISRs, we have the ASR 1Ks, and we have the ASR 9Ks. It's kind of 3 distinct platforms. And the 1Ks just happen to fall into the ASR marketing branch for marketing platform line. I don't know. But Cisco decided that they would be ASRs, not ISRs. Last but not least, we have virtual versions of both of these. So these would be to deploy to our data center, to our cloud instances. And we do have 2 different options available. Now, these two, the ISRV and the CSRV, have feature parity with one another. However, and when I say that, I mean like OSPF, BGP, etc. Like the capabilities are really there in both of them. But the ISR is designed to go into this ENCS box. I believe it stands for Enterprise Network Compute System. Don't quote me on that, but I believe that's what it stands for. This is essentially a server that has so many slots from a memory perspective, and you can populate each slot with a virtual network function. So VNFs or NFVs, sometimes these are called network function virtualizations, but we can deploy an ISRV onto fill up one of the slots. We could throw a virtual wireless LAN controller we could deploy into one of those slots. And so we kind of pick and choose which of these we want. And then this is really cool, by the way. So you log into this interface and you can create the internal network. So you can say that the virtual wireless LAN controller connects to the virtual router via an internal connection. And because it's all virtual, you can just connect whatever you want to whatever you want. And it comes with a lot of templates. So it's like, hey, you've got a virtual wireless LAN controller and you've got a virtual router. When we have these, we usually cluster them together like this. Is this how you'd want to configure it? So it's a really cool box. I love these boxes. They're basically designed to go out to remote sites instead of a router because they're really extraordinarily flexible. The other cool thing about the NCS is that we can deploy hardware components. So this actually comes with, in some cases, a network interface module. So this voice over IP concept that we talked about, I might need to slide a voice over IP module into my router in order to enable it. Well, I say, well, if I'm going to deploy the ENCS, I would lose that. Well, no, actually, because the ENCS can support router modules. It's designed for that. And so we connect that in, and internally it traces that into the router. And so it gives our virtual ISR, even though it's a virtual router, it gives it access to a voice analog line. So it's really cool how this box comes together. So that's what the ISR is primarily designed for, because, again, it's about features. But as in virtual format, unless it's paired with the ENCS, you usually don't get access to many of those features. However, that's where we have the CSRV. The CSRV is a little bit more based on the ASR line, and so the CSRV, even if you deploy it to ENCS, it can't take advantage of the VoIP features and such, but you could deploy it out to the cloud, for example, and there's no real value in deploying the ISRV to the cloud because you can't take advantage of the feature set. But the CSRV can go out to the cloud, and it can scale up and be as big and bad of a router as we need in the cloud or in our virtual space. So again, a place for both of them, but we need to understand the differences there. Now, let me make sure I covered everything. Any questions about routers so far, feel free to ask in the chat. Okay, that all looks good. So these 8,000 edge platforms, these are designed, everything we just talked about is absolutely true, and even better, these are all functioning within the world of SDA. The Catalyst 8000s have not been enabled for SDA as of the time of this video. So when well, I guess I haven't said it yet. The Catalyst 8Ks are going to be the spiritual or the successor to the ISR 4000s and the ASR 1Ks. Okay? Specifically, we're going to have 8300s. And 8300s are essentially an ISR. And then we also have 8500s. And the 8500s are essentially an ASR, specifically an ASR 1K. Lastly, we have the 8000 virtual router, the 8000V. And that, as you can imagine, replaces the ISRV and the CSRV. They say, well, Jeff, why aren't we deploying Catalyst 8Ks? Well, for the reason I just mentioned. They're not supported yet in SDA. This is one of these situations where chances are things are going to change before the ENCOR exam gets to evolve. In other words, by the time you sit down and take the ENCOR exam, the 8000s might have replaced all of the other routers. The other routers might all be end of sale. I doubt that. Cisco will probably keep those going for at least another couple of years just to support existing customers. A customer who has 500 ASR 1Ks and they're going to buy a new router, they'd probably like that 501st to also be an ASR 1K, even though the 8000s are out. Okay, so Cisco will probably keep those platforms going for a while, but at the same time, when we look at the where we're going, where Cisco is going to want us to stop purchasing ASRs and ISRs and start purchasing Catalyst 8000s. And again, if you're like me, I hear Catalyst and I think switch, and that's just not how Cisco is doing things anymore. Catalyst 8000, okay, again, it's an edge platform, it's a router, okay? It's an ISR, it's an ASR, it's a virtual router, however we want to describe it. Yes, edge platform is the official correct way of describing it, but understand that it is the new router platform. So, that's basically what I mean. When you talk about the 8300s, again, you're going to expect to see VoIP features. You can expect to see servers. You can expect to see security and such. The 8500s, its focus is going to be on performance. You're not going to see any modules on the 8500. You're going to see all of the NIMs and the services modules or the SMs. These are all going to be on the 8300s, but they're not going to be on the 8500s. So what I said earlier, remember, I said, okay, well, the ISRs, you got the ISRs, and you got the ASR 1Ks, and you got the ASR 9Ks. Well, the ASR 9Ks are going to stick around, and now they're taking that ASR line and that ISR line and kind of bringing these together into the Catalyst 8000s, okay? Including the virtuals. Again, we've got the 8000V, which, by the way, the 8000V supports VXLAN. It's interesting because we're clearly using VXLAN from an SDA perspective, but I I guess at this point we're just not supporting any of this yet within the world of SDA. Cisco, I guarantee you, Cisco is running all kinds of quality assurance or QA on Catalyst 8000s in software-defined access as we speak. It would shock me if they didn't already have customers running SD-Access on Catalyst 8Ks from a testing perspective. So again, I just want to emphasize, and I think I may have gotten off track. What I started to say was we might have this situation where you're sitting down to take the exam, and these are really where you'd want to go, to purchase hardware for SD-Access. Again, not today, not the time of this video, but by the time you're watching this and you do a quick Google search and you see, 8000s are supported now, you might sit down to take the ENCOR and they might ask some kind of question about what are the valid components for deploying SD-Access, and they don't list Catalyst 8000s. Don't be surprised if that's the case, because at the time of the ENCOR being written, it was all about ISR 4300s and 4400s and ASR 1Ks. So that's why we spent time covering all of that, because even though it's arguably old at this point already, it's very important that we understand sort of the history of where we were, because as much as anything, Cisco might ask us. But from a less exam-focused mindset, we also need to know and understand how networks have been built, and even today we could still build SD-Access on this technology, mentioning earlier that situation where it might make sense to purchase older hardware. There are reasons for that. All right, so any thoughts or questions, be sure to ask about that. We are moving on. We are moving on to the wireless world. So, what does wireless look like from a hardware perspective? Well, modern day, we mentioned it earlier. So we have Catalyst 9100s. These are new access points by Cisco, a whole new line of access points. And then we have Catalyst 9800s. And the Catalyst 9800s are wireless LAN controllers. Again, Catalyst doesn't mean switch anymore. Catalyst means whatever Cisco wants it to mean. Catalyst means that it's Cisco's primary line of hardware for the campus environment, for the WAN environment, for the core, basically everywhere but the data center. At this point, we have Catalyst devices and we have Nexus devices. And so Nexus belongs in the data center, Catalyst belongs outside the data center. That's a little bit where we've broken down. Furthermore, I suppose service providers still got the ASR line, for example, and the ASR 9Ks especially, and some other things. So Catalyst doesn't mean that anymore. That said, we can support some of the older platforms. Specifically, from an access point perspective, we can support Wave 1 and Wave 2 access points from 802.11 AC. So this would be like the Wave 1 was the 1700s, 2700s, basically X700s, right? 1700s, 2700s, 3700s. The Wave 2s, you remember, are the X800s. So the 1800s, the 2800s, the 3800s. These are still supported. Wave 2 are fully featured, but Wave 1 is not. There are some features missing. I'm not clear on what those features are. I've only found Cisco documentation that warns that some features are missing without saying what features those are. So if you're going to deploy software-defined access using Wave 1 access points, then be sure to ask your Cisco rep, what's up with that? There are these, I'll be honest, I'm not, this is straight from Cisco's documentation. I've never worked with these access points. I don't know what they are, but we'll say it. The 1540s, the 1580s? No, 1560s, and the 4800s, okay? These are, I believe, smaller business type of applications. If you've worked with these, chime into the chat or make a comment to let me know what exactly these access points are, but that's, just keep that in mind. If you're working in a network that has these access points, then it's not Cisco's main line of access points, but it is, they are supported inside of SD-Access. From a wireless LAN controller perspective, we've got the 3504s, we've got the 5520s, and we've got the 8540s. Okay. These are they called them Air OS. Okay, so I mentioned, right, back, this is like 2005 time frame. Fresh out of college, electrical engineering degree in hand, and I was asked to really learn this new wireless LAN controller world because Cisco just acquired that company called Airspace. Airspace with an E, which is not how we do it in America, at least. I don't know if that's a British thing. But either way, Airspace and Airspace controllers ran Air OS as the operating system. And so I remember having to learn, like, oh man, I've just been learning all this stuff about iOS. Now I have to learn Air OS commands. And at the time it was like, Cisco always acquires these things, and eventually they just, they'll get rid of Air OS and they'll put iOS on there. Like, oh, okay, cool. So eventually I won't have to worry about Air OS. And here we are today in 2020, still having to worry about Air OS because it's on these older platforms. But finally, the Catalyst 9800s are running a version of iOS XE that's built for wireless LAN controllers. So kind of cool that we have finally arrived there 15 years later. I'm glad I didn't wait to learn the product, but just be aware of that. All right, that's it for wireless. I'll go ahead and keep that on the screen for now. The other thing, I'll just squeeze it on here. The other thing we need to know are these extended nodes. I mentioned this in the intro. The extended nodes is an interesting concept because essentially what extended nodes are, Cisco would love to say, hey, the Catalyst 9Ks can cover everything for you, and clearly it can cover a lot. It can cover everything from layer 2 edge switches to layer 3 edge switches and chassis and cores and even wireless LAN controllers and access points. That's great. But Cisco developed several platform lines that they call, that are dedicated to what they call non-carpeted workspace. Okay, so when I think about a carpeted workspace, what am I thinking of? Primarily white collar type of, people sitting down at computers and doing things, office space. Okay, that would be carpeted places, and so that's where we deploy our Catalyst 9100s, and maybe even in the closet right nearby is a Catalyst 9800 and Catalyst 92 or 9300 running as the switch. I mean, that's the idea here. Is it's clean, it's temperature controlled. The non-carpeted workspaces would be places like factory floors and warehouses, places that maybe have stuff in the air, chemicals or vapors or metal shavings or what have you, a little bit more robust and not temperature controlled. You don't air condition necessarily a warehouse. And, some factory floors get really, really hot. Or cold in the winter. So you don't necessarily heat either. Some of the employees have heaters nearby, but you're not heating the entire space. And so you might end up with devices that are regularly exposed to sub-freezing temperatures. So Cisco has several product lines that were made for this. The biggest one would be the industrial Ethernet switches, or series of switches. There are several of these. And then they also have the 3560-CX. This is an interesting switch. It's fanless. It's intended to be quiet, but it's intended to go wherever as well. And then these, I forget what those are called. Cisco, it's CDB. It's Cisco something business. Digital? Is it Cisco Digital Business? Let's check real quick. Cisco CDB switches. Digital Building Series. Okay, my bad. Cisco Digital Catalyst Digital Building CDB. Yeah. So, intended to connect our HVAC systems, our audiovisual, smart building systems. All right. So these platforms were developed. I clearly have not worked with CDB switches, which is fine. Cisco designed these to serve a particular service, and the Catalyst 9Ks, at least at this point, let me write a better 9. The Catalyst 9Ks at this point can't do any of this stuff. Because the Catalyst 9Ks can't do any of this stuff, Cisco wants to support this. But there's a different problem that we have. Because we're about to talk about the fact that Cisco can support some older hardware, but that older hardware is still going to have the UADP chips. These devices do not have UADP. So in other words, things like VXLAN, they're not capable of VXLAN. Things like Lisp, they're not capable of Lisp. So how do we connect these devices in such a way that they're still supported? And so really, long story short, what Cisco's doing here is they're going to have DNA Center view these extended nodes, manage the extended nodes, but they're not going to be part of the overlay. Okay, an extended node, if I can draw it down here, an extended node is going to connect up to a Fabric Edge device. So we've got a Catalyst 9K here, let's say, maybe it's a 9300, and then we've got one of those great CDB switches that we don't know what they're for. And we deploy that, and we connect it directly to the Fabric Edge device. And when it's directly connected, we can still extend our policy information. So here's our users connecting into the CDB. And as those users are entering in some way we can enforce the policy via these extended nodes, which is the goal. We want to make sure that we have our security everywhere. And so now, when I say we can support policy, it's still going to have to go up to the Catalyst 9K in order to get enforced, because we don't have the ability to run Cisco TrustSec on these extended nodes. Again, they're very limited. All it really is, it's a set of automation tools that's going to help us manage these extended nodes that are hanging off of our Fabric Edges. Okay, so it's not something that gets a lot of attention. It's really nothing I would argue we even really need to be super aware of in most design cases, but obviously for those of us who do work with factories and warehouses and such on a regular basis, this could be a big deal. From an exam perspective, I would absolutely say that according to the blueprint, these are on the blueprint, I would absolutely expect a valid question could be, which of these devices are supported? And you might see, I don't know, like Cisco Catalyst 30, like let's say it's like the 2960s and the 3650s and the CDB switches and the 4500X. I'm truly making this up as I go. And it might be select two, which two are supported. And you're gonna be like, well, we're about to find out that the 3650 is supported. The 2960 is an old bad switch. But then you're looking at it and you're like, maybe the industrial Ethernet switch is on there instead of the CDB or whatever. But you're going to be like, I've heard of the 4500X. I know that's a really good switch. And those CDB switches, I've never heard of those. I don't even know if they're real. So I'm going to select the 4500s, and that would be a wrong answer. Because the 4500s are not supported, and the CDBs are. Industrial Ethernet switches are. And so this is where we would want to make sure that you understand. And here, really, I'll circle it in a different color. This is our answer right here. Just these three lines of switches are our extended nodes. As of the time of this video, as of the time of the current ENCOR blueprint. So if they ask something about extended nodes, or they throw these in there as part of valid software-defined access hardware components, there you go. There's an answer for you. Those three, understand that on top of everything else we've talked about so far today. What time we got? 48 minutes. All right, so we've got just about 12 minutes left. We are wrapping up. We're actually on a pretty good schedule here, but I will pick up the pace just a little, make sure we get out on time. So next we got to talk about controllers. When are we going to talk about old stuff? I thought we were talking about old stuff here soon. Okay. I think it's... I took it out. Apparently I took it out as a dedicated session, or maybe I skipped over it. No, I don't think I skipped over it. All right, we'll talk about it right after this. All right, so we will go a little bit fast here. That's okay. My pen got darker for some reason. Well, I don't know why I care. All right, either way. So controllers, what do we got here? We got two controllers we need to worry about. We've got DNA Center, and we have the Identity Services Engine, or ICE. I'm going to try to... Why did it get dark? Is it... All right, well, let me just change colors here and see if that's... No, that's dark too. Every now and again, this art program does get me with something. All right, well, I mean, it is what it is. We'll just keep rolling with it. So DNA Center, here's the big thing about this. When we're deploying hardware and software, these controllers, DNA Center, as of the time of this video, is still hardware only. Cisco has made noise about a cloud DNA, I'm getting warm, I'm going to take this off, a cloud DNA Center instance, cloud managed, etc. That I think they do have it going a little bit, but like when you, anyways, I haven't seen it officially launched yet. It might have officially launched at this point, but for right now, again, especially as far as ENCOR is concerned, it's a hardware-only solution. We can deploy it as a standalone appliance, so standalone, or we can deploy it as a cluster. If we deploy it as a cluster, that would be a cluster of 3. What else? We are on the 2nd generation. They call it Gen 2 of DNA Center, and there are 3 different models to choose from. So it just depends on the size, the amount of devices, the amount of users, the amount of edge devices, etc. All of that is going to go into the calculation, and when you're doing this design, you can use the data sheets or otherwise work with a Cisco rep to make sure that we've sized out our DNA Center appropriately. But again, because it's hardware only, we want to make sure that we nail that. And unfortunately, because it's hardware only, it's really hard to lab this stuff. It's really hard to get DNA Center in a lab because I can't just download a virtual machine and throw it into a lab environment. And so this is a limitation that a lot of people studying for software-defined access run into. We at CBT, we actually had to buckle down and get some DNA Center hardware in order to make it work, in order for us to do our SD-Access series, our course. But, so it's not easy. And if you're finding yourself scratching your head saying, how do I get access to DNA Center? You're not alone. It's very hard to get access to it, dedicated access. Cisco does have some sandboxes out there, so be sure to Google search that real quick. But understand that at that point you're sharing it with other people, you don't have administrative access, and so there's limitations there as well. dcloud is another option. Demo Cloud it stands for, but it's dcloud.cisco.com. You can check out some DNA Center labs in there. So next we have ICE. Now ICE, the difference is we can deploy it as hardware, but we can also deploy it as a, I'll say software, but really it's a virtual machine. So we can deploy that. That does cluster for larger scales. The clustering is really less of a redundancy issue and more of a, ICE as an application can be run as a single virtual machine, and it runs, like 4 different functions in that one virtual machine, and this is for smaller, medium-sized environments. But then when we get to enterprise, each one of those functions is going to be its own virtual machine. And so then these get clustered together in some way. And so this is where, just depending on how you deploy ICE, this is going to be something you are going to rely on Cisco to help design, or a security engineer if you are in that role, or you know somebody who is in that role. Virtual machine, this can run in VMware, it can run in Hyper-V, but I believe that's it, actually. Oh no, it can also run on Red Hat KVM. My bad. So we can run it on any of those. If we were going to deploy it on hardware, Cisco actually has something they call the Secure Network Server. And I think it's a lowercase n, so I hesitated there. But I believe it's SNS like that. The Secure Network Server, I don't know why. Maybe it is capital. I don't know. I don't know which one looks better. But either way, SNS, they've got 3 different models of this, similar to the DNA Center, I suppose. So depending on your scale, you can deploy the right one. But that's all the time we have to spend on the controller, I believe. That's really everything I wanted to cover. It was a little fast, but if you have any questions, feel free to chime into the chat. Just, we spend so much time talking about all of the different, just like how the fabric works, right, with our edge nodes and VXLAN and Lisp and all of that, but we forget sometimes, at least I do, that's like, oh yeah, there's a controller out there as well that we're logging into and doing all of this from. So keep that in mind. Okay, so really quickly, where are we at here? Ooh, yeah, we gotta keep going. So older components. What is supported on Cisco, from Cisco's perspective here? And this is a good segue into what we're going to be looking at next is like the you'll see, it is a compatibility matrix. The key here is when we are talking about older equipment or even newer equipment, each piece of hardware in an SDA environment has to be mapped to a role. So we've already mentioned this a little bit. If I have a 9300, I might map that to a fabric edge node. And if I have a 9200 and I want to map that to a border node, for example, that's not going to fly. Cisco doesn't support 9200s as a border node. And so we're going to take a look here in a moment to see that there is a compatibility matrix on Cisco's website that we are always going to want to check before we deploy hardware in a particular role. I don't want to go out and buy a Cisco 9200 to be a border node and find out after the fact that it's not supported. So let's make sure that we are doing our due diligence in our designs, and really going out and looking at the compatibility matrix is the best way to do that. So back to the older equipment, we need to know which equipment is supported as well as which role it can go into. The biggest success story, remember we talked about that UADP, I told you we're going to come back to this. The UADP is programmable, and what exactly does that mean? Here's the best example I can give. This UADP saved Cisco's bacon, like not even joking. It might well have saved them as a company, and or at least made it so they could stay relevant in this space. Because Cisco had a big problem. They released, remember the 3750s and 3560s, those are very popular platforms. And they're ready to evolve those. And so they developed the 3650s and the 3850s. While they were developing these, this concept of software-defined networking was picking up and gaining some traction, but Cisco really felt like they had some tools baked into the 3650s and 3850s that would align with software-defined networking. And they did. They had some things. OpenFlow was the biggest thing, I suppose. But it wasn't enough. And so Cisco released the 3650s and 3850s, and everybody started replacing their 3750s and 3560s with these two platforms. And Cisco sold a bunch of 3650s and a ton of 3850s, which sounds like it's a good thing. Other than this SDN thing really caught on, and Cisco was like, we need to develop this concept of software-defined access. We need to be leaders in this space. This is where this becomes a problem. Because I can't go out to especially my large customers. You think about worldwide networks, and you think about large enterprises that are deploying thousands of these routers. I can't go to them and say, hey, we missed the ball on this, and 2 years after the fact, we're going to release the Catalyst 9000s. Sorry about that. Hey, we'll give you an extra 5% discount on these 9K switches. Yeah, that's not going to fly. Fortunately, and so here's the big problem. SD-Access is built on two technologies. We've mentioned them several times. VXLAN and Lisp. The big problem here would be VXLAN. Because I need to be able, Lisp can be a little bit more control plane software driven, but VXLAN is data plane traffic. And so if I want my 3650 over here to communicate up via VXLAN to somebody, well then, I mean, remember this conversation, right? I could push VXLAN into the 3650 via software, but that's not going to result in good performance at all. In fact, it's probably not even worthwhile for me to try, because it's going to be really bad performance and everybody's going to be really upset. And so that's a huge obstacle. This is where the UADP came into play. Cisco is able to actually reprogram the UADPs such that now they support VXLAN. This is incredible. These devices, when they shipped, we had no need for VXLAN. VXLAN was not on the table. They were not able to support VXLAN in hardware. And with a software update, not only does it support VXLAN, because that's not that magical. Again, we could do that in software. They support it in hardware. Saved Cisco's bacon, saved so many potential rip and replaces and upset customers. A huge success story for the Unified Access Data Plane, or UADP ASIC. Huge success story. And so now these devices can support VXLAN, and as such, now we can map these to roles. For example, the 3650 can be a Fabric Edge node. The 3850 has a little bit more horsepower, so it can be a Fabric Edge node, it can be a Fabric Border node, it can be a Fabric Control Plane node. Now, I've thrown a lot of these out there at you. For example, I have said over here that a 9300 can be a Fabric Edge node. In fact, it can be a Fabric Border node, but a 9200 can't be a border node. And over here, we see that paralleled with the 3650s and 3850s. So we fortunately don't need to memorize this for the most part. From an exam perspective, from an ENCOR perspective, we do need to have some of this down pat. And it's not that hard for the most part. Lower end devices can be fabric edges only, and higher end devices or switches can be fabric borders and control plane nodes. We just kind of need to know where that dividing line is. And then routers as well are focused on border and control plane versus being fabric edges. So what we're going to do is we're going to flip over now. I hope this works. Yeah, let's see, I keep having this problem. And I'm really not sure. Hold up real quick. I'm going to try. Huh. There it goes. Oh my goodness. I have no idea what is going on there, but it works beforehand. It's like it just stops working after a few minutes. I'm not exactly sure why. So sorry about that. All right, so we are at our time limit, so if you need to go, understandable, but we've got just a few more minutes here. Here's what I want to show. When you go to go to Google and search for Cisco's SDA Compatibility Matrix, you're going to find that it's the first document. So we click on this. This used to actually be a true document. Now it's more of a dynamic tool, which is really cool. So you can see we can click New Deployment here. Let's say we're just deploying new software-defined access. And so we can pick our release here. If we're deploying a new release, we're probably going to deploy it on the latest. And let's see all of the different fabric edge nodes that we can deploy. So we hit Submit. And we start to see, oh look, the 3850s, the 3650s, these can be fabric edge devices. 4500Es, notice what it says. We always got to look at the caveats. Supervisor Engine 8E and 9E. The reason for that is because Cisco started including the first version of UADP inside those supervisors. So again, that's great, but the old 7E supervisors, those don't support UADP, or they didn't have UADP, and so they can't support VXLAN. Which is why, incidentally, the 4500Xs, even though they're a fantastic product, they were built on Supervisor Engine 7E technology, and so they don't have the UADP in them, which is why 4500Xs do not show up on this list. We see the 9200s, 9300s. We can always come over here and see the full list of hardware that's supported, which is great. The minimum version of iOS XE we have to be running. 9400s, 9500s. So, you know, again, it's learning the cutoff. 9600s are not supported as fabric edge nodes. They're call them too powerful? I don't know. Because the 9600s parallel 65s and 6800s, we can expect. Also, we don't see 65 and 6800s on here. However, if we go up here and we look at control and border and control plane nodes, we're going to find a lot of routers, but also some switching platforms. For example, again, we've talked about the ASR1Ks are supported. 3850s, not the 3650s, but 3850s are supported. 6500s and 6800s, and as we scroll down, we see the 68 40Xs and 80Xs, and all the way at the bottom, we're going to see the 9600s. These are all supported. Big switching platforms, right? 9300s, 94s, 95s, again, 96s. ISR 1000Vs, great. 4400s and 4300s ISR, or 100 ISRs. And this is an interesting one. Nexus 7700s, but they have to have specific hardware, and they can only be not just a border node, but an external border node. They can't be an internal border node or a control plane node. So I'm sure 100% guarantee you that was put in place because a large customer demanded support for it. Is something that specific is usually what's happening there. But you still, again, we do not see Catalyst 8000s as of the time of this video. I'm hoping by the time you watch this that maybe the Catalyst 8000s have been added to this document. But that just emphasizes the value of having a living document like this. We absolutely want to make sure that we're focused on not making any baseless assumptions about what hardware support or what role. We simply come out to this matrix and we check. Now, from from an ENCOR perspective, just the exam, there is some level of memorization we should do here. You should know that the 9600s, for example, aren't fabric edge nodes, but they can be control and border nodes. Do you have to have the whole matrix memorized? No, but it's not that big either. So just spend a little bit of time familiarizing yourself. Again, for the most part, it's fabric edge nodes are going to be at the lower end to the middle, and then fabric control plane and border nodes are going to be middle to higher. Within the Catalyst 9K line, that makes it really easy. The 9200s are the only ones that are fabric edge only. The 9600s are the only ones that are border and control plane node only. And so spend a little bit of time memorizing it. It's fair game on the ENCOR exam. They could ask a question about which of these devices would work as a fabric edge node. So be aware of that. But in the real world scenarios outside of ENCOR, You don't have to have this memorized. In fact, you shouldn't rely on your memory. You should always come out and validate before making any decisions, purchasing or configuration or otherwise. Okay, so now we are 5 minutes over. Thanks for those who were able to stick around a little bit extra as we wrap that up. But this concludes software-defined access, everyone. I mean, there's a lot of content here that we've burned through. It's all archived on this YouTube channel, so go back and watch it as many times as needed. As always, we've got a ton more content on CBT Nuggets website. It's where I work for a living. We've got, in fact, I just worked with Notch Hutchinson and Keith Barker to put out an entire course all on software-defined access. A lot of what I cover in the course is just like a third of what's in there. Because I do a lot of the same type of thing from a Blackboard perspective and detailing out how things work, but then Knox and Keith actually lab it up and they show you what DNA Center looks like and they walk you through all the configuration steps. So just a fantastic course that if you're hungry for more information and you are a CBT Nugget subscriber, go out and check it out. If you're not a subscriber, sign up for the 7-day free trial and then check it out. So with that, I'm going to hang out here for another 5 to 10 minutes just to answer any questions that might arise. So if you have anything, chime into the chat. Otherwise, importantly, we are taking just one session off, really. We're going to take off because it's going to be right between Christmas and New Year's. So wishing everyone a very happy holidays. We're happy end of the year. A lot of people are going to celebrate 2020 ending. No promises that 2021 is going to be any better, but at least there's hope there. I know for all the bad that's happened in 2020, it's been a lot of fun to just do this, to talk about technology and to build up our knowledge around software-defined access. I know at the start of the year, I didn't know nearly as much about software-defined access as I do now. And I hope that's the case for you as well. So that's just one example, of course. But all that to say, we are going to continue on in the ENCOR blueprint in the next session, which will be in January. We're going to be talking about switching mechanisms. So you think about CAM space and TCAM space and what exactly that's all about, Cisco Ceph and such. It's going to be a fun conversation. It's one of those things that when you're in the thick of it, you don't really think about how things are happening under the hood. You just care about configuration commands, at least I do. And so to actually open that up and make sure we understand what all these different tables are doing and how packets are processed and such, that's what we're going to be covering. So come hang out with us next time. We'll see you there. In the meantime, again, hope everyone has a happy holidays, and we'll see you next time. Bye-bye.